Let's do this example 3. If Sean walks 2 kilometers east, then 4 kilometers south, what is his displacement? So he has two movements, one after another. These two are displacements. Can you please draw a sketch to show this movement? Pause the video now, draw a sketch of his two displacements, show how you draw an arrow to represent his final or total displacement. And you may label 1, 2, and 3 at the endpoints, the positions where Sean would be. When you're ready, start the video again to see my diagram. So here's my diagram. What I need to write here is that east is to the right and south is downwards on my diagram. So position 1 to position 2. This is the first displacement, an arrow pointing to the right, which is my east, of 2 kilometers. And then immediately following a 4 kilometer south displacement with an arrow represented by an arrow pointing downwards on my page. Always label your vectors. This is essentially a vector, a sketch of a vector. And so if you add these two displacements, you get this total displacement. Remember, the total displacement only cares about where you were at the beginning and where you ended up. So from position 1 to 3, you can draw an arrow, and I've drawn a dotted arrow to make it look different. And it's an arrow pointing sort of southeast direction, down to the right on your page. So the size of this side of the right angle triangle is the magnitude of the displacement we're looking for. So this arrow represents the displacement from position 1 to 3, initial to final position. Pythagorean theorem is, if you recall, it's for right angle triangles, and it's the relationship between the hypotenuse or the longest side of the triangle. The longest side of the triangle happens to be the displacement we're looking for. It's opposite to the biggest angle of the triangle, 90 degrees. So hypotenuse squared is the sum of the other two sides squared. And I'm just writing this out. You may see it usually as c squared equals a squared plus b squared, but here I'm writing it out related to our diagram. So substituting the numbers in, the magnitudes for our displacements, and calculating, we get rounding to two significant digits, 4.5 kilometers is the magnitude or size of our displacement. Our answer does not stop here. It's a displacement, which remember is a vector. Vectors have direction. So how do you describe the direction of this vector here, displacement? We can't just say it's southeast, because if you say southeast, it means exactly 45 degrees between south and east. We need to find what this angle actually is. If this was a scale diagram, you could use a protractor, we can use a trig ratio here as well. And so this theta represents the angle. The opposite side is this 4 kilometers, and the adjacent side to this angle is the 2 kilometers. So the ratio of 4 kilometers over 2 kilometers, this is what tangent of an angle means. So tangent of an angle is opposite over adjacent. You end up tan theta is equal to 2. You can inverse tan using your calculator to find the angle, rounding it to two significant digits, 63 degrees. Two significant digits, this is a measurement. An angle is a measurement. It's based on two measurements, the 4 and the 2 kilometers, which each had two significant digits. So your final answer is Sean's displacement is 4.5 kilometers, and in the direction should be in square brackets. You can say east 63 degrees south, because what you're saying is this angle 63 degrees is if you start from the east direction, you swing 63 degrees south. Okay. Otherwise, you could use the smaller angle. 90 degrees take away 63 degrees is 27 degrees.